is Mr. Chiranjeevi and Ms. Rathinam. So we as a team have taken up the title Cycle Time Reduction in the Defect Rectification of EJ-band Processor, which is used in Sanket Mark III and S projects. So we represent Bharat Electronics with a vision of becoming a world-class enterprise in professional electronics. We come from the Hyderabad unit of Bharat Electronics, which is responsible for the manufacture of electronic warfare equipment. Coming to the project details, our prime motto was to reduce the cycle time from existing 322.1 hours to a targeted cycle time of less than 120 hours. So this slide shows our Six Sigma organization chart, and the champion of our organization has given us multiple project titles for our Six Sigma presentation, and we had to do the project prioritization matrix based on the weightage to criteria is a 159 scale, and obviously the cycle time reduction and defect rectification has stood the top because of top scores on all the factors that we have considered. Coming to the definition phase of the problem, the main thing was to reduce the cycle time in defect rectification. That too, the scope was after the DIDR activities onboard ship. Having seen the project details, customer, operational, market and people aspects of the project, it is worthy to see the financials as well. Having 21 AMCs in hand, it is amounting to around 28 crore per year as a business case. So this slide shows the milestone chart that was planned.
And these are the Indian naval platforms, and this is where our Sanket systems are being installed. Next. So this is how the Sanket system installation look like, and see how difficult for it is field engineers to access these units if any problem comes in future. So basically Sanket is an ESM system. The main objective of this ESM system is to detect the enemy radars at mid-sea, and it has to give what the parameters of the radar in this frequency and the direction of arrival are the two important parameters, and 2 to 18 is the present scope and which is being covered by the EJ-band processor in Sanket. So this is the total system configuration, and this is the EJ-band processor we are talking about. So the main motive for selecting this project is from the voice of the customer. So what we are doing is, despite completing all checks at harbor, system is not performing at sea. So these are the messages, fax message we have received from the customer that the system is not performing at sea even though completing all checks at harbor. So this is the defect he is mainly worrying about. This is the defect look like, and the DOA part is missing. And if everything comes okay, this is the display should look like. So when coming to the nature of the project, it is basically a TOT-based project from Indra Spain, in which 20% of the parts we are still procuring from Indra, and which are very, very costly, and lead time is also 24 months. So why this gap is coming? So system is performing at harbor, system is not able to perform at sea. So there should be some gap, or the frequency and DOA is the first thing we are unable to check at harbor. Second thing is own radar planning interface we are unable to check at harbor. This is nothing but we can say that system interface with other systems in the ship.
Finally we have selected the problem as problem statement is it's more cycle time that is being taken in the defect rectification of the EJ-band processor, that too after the successful DIDR activities on motion. So this slide shows the support diagram. The team has brainstormed and identified all the various processes that are involved and the supplier in-out customers for each process. And we have identified two CTQs, Y1 and Y2, and for each CTQ Y1, Y2 and Y, we have written the specification, defect definition and the canvas status. So coming to the measurement phase, before we actually proceeded for the measurement of the data, we have tried and plotted what we wanted to measure, what kind of data, how are we going to measure, then where from and how the data is going to be recorded. So we have decided that we are going to take data from 7 ships which we have proved from 2020 to 2024, and for all the 7 ships we have collected the cycle time data of Y1, Y2 and Y. So for all the data that is collected, we have proceeded by calculating the mean standard deviation, then the normality, stability and the process capability was measured for Y, Y1 and Y2 as well. So
when we have started analyzing this using the process map for y. This process map of y is nothing but combination of y1 and y2. When coming to the process map of y, we found that some bottlenecks in the process. Field engineers are mostly relying on the trial and error method to address the defects among the OEM cards. And the second thing, we are unable to check frequency and DOA combinedly at hardware. And coming to the Y2, we are completely relying on the C trace to know the effectiveness of the bone radar blanking. We are unable to verify this at hardware. So to know all the possible causes for this long cycle time, we have brainstormed with our team and mapped this using the cause and effect diagram, and we have found primary, secondary and tertiary causes. And all these causes, we have gone for the cause validation, and we have found some potential root causes, and these potential root causes we have labeled them as CS1 to CS9. Yeah. Now, after this, for these 9 potential root causes, we have collected the data, and this data we have analyzed using the Pareto chart to know which is contributing more, and we have found that the 3 important causes which are contributing more, these are called the root causes for this long cycle time. And these 3 root causes we have analyzed using a CNX diagram and found that all are controllable factors only. There are no noise factors and there are no experimental factors. So then we have started analyzing these C factors, and we wanted to give solution for the 3 things, such that first, frequency and DOA we must verify at hardware, and the effectiveness of the bone radar blanking we must verify at hardware, and we have to give some clear-cut solution to the field engineers such that how to isolate the defect among the OEM cards. These 3 things we wanted to give the solution. So by keeping all these things in our mind, we have gone for the improvement phase, and this is the we thought of designing some jig such that all these C factors must be addressed. So this is the jig we are talking about. This jig will have 3 rotary switches. Each switch will have 6 positions. So by keeping these switches in different positions, we can simulate the DOA from 0 to 360 degrees at different level, so that the frequency and DOA combined we can check at hardware itself without going to C trails. So the input to the jig we are taking from signal generator and pulse generator, and the output of the jig we are giving to the processor. In this processor, the card fits inside this processor. So depending upon the switch position, the processor must read the different types of DOA, so that the first problem, frequency and DOA combination, we have addressed with this jig. Second, then again we have analyzed this using the process map, and then found that so there is no back and forth for this entire operation. So for second problem, also by using jig we have given the solution such that if it is failing at step 1, replace card 1. If it is failing at step 2, replace card 2. Such that now there is no trial and error method. We have completely eliminated the trial and error method. For Y2 also, as we are able to verify frequency and DOA at hardware itself, so that we have completely eliminated the dependency on the C trails for Y2 also. So we have implemented this in 4 shifts, and we have collected the data after improvement, and these are the targets that were set by the management for Y, Y1 and Y2 individually. So then for this data we have gone for the statistics part, and we have found mean standard deviation, and then first we have seen whether data is normal or not. Then we have gone for the process capability, and we have calculated the jet for Y, Y1 and Y2 individually. This is for Y1, Y2 and Y2. So to know whether all these results are significant or not, whether this improvement is significant or not, then we have gone for the 2-sample t-test and found p-value is less than 0.05, which is indicating that it is purely a significant improvement.
Having seen all the improvements, coming to the verification of the tangible benefits, here the cycle time is clearly improved from 322.1 hours to 109.5 hours. Considering that we have around 21 AMC, AIMC and RRB in hand, the total savings per year was around 1,750,000. This calculation was made from the data that we got from IED, and the financial savings were vetted by our unit finance analyst. So the problem where we started was from the voice of the customer. The customer was not satisfied because the system was failing even after proving the DIDR checks on board ship. But here, after all the project, the customer is finally, we have gained the customer trust and confidence, because the customer is now confident that the system is definitely going to work in C after we have proved the system in HATS, because all the simulation of SATs were being done in the HAT itself. And because there were no multiple trial and errors when we go to the sailing, the field engineers have now built up their morale because they were able to identify the problem directly without any trial and error. And they have a much work-life balance because they were not going to multiple sea trials. And we have also eliminated the requirement of the full system for having to check the parameters of frequency and DOE. And basically we started utilizing the field engineers for different other works. So having seen all this, moving to control phase, which is very important for this project to maintain the sustainability, we have taken a new part number for the test rig that was designed, and we have created the PL and SOP documents, and all the documents are updated in the SAP system of DE. And we have also taken care that the due training was imparted to the field engineers, and then we have created an ATP document that was given and explained to the field engineers. The SOP of the test rig was also documented and it was shared to all the engineers. And as an initial step, we asked the field engineers to fill the sample TDR and send this sample TDR to the headquarters so that we verify that all the proper methodology is being followed on board ship or not. And then we have taken, studied the sustainability for 12 more months from January to December after our project was completed, and we have found that the process is under control. So for Y1 and Y2 we have done that. And then this slide shows that there is a significant improvement in the mean because the cycle time is obviously reduced. And the standard deviation improvement also was significant because there was now no trial and error, and there is a sure-shot method of identifying the problem, and there was no deviation in the cycle time that we were obtaining. And there is a clear improvement in the Z value as well, where it was 0 in the previous cases, where it is significantly improved now for all Y1 and Y2. These are the list of tools that we have used for the various stages of the Sigma project. And this slide shows the comparative milestone chart, where we have slipped around 2 weeks in the analyzed phase as per our plan. However, we could cover it in the improvement phase. So, thank you for patience.
Very good presentation, and the data set is deviation is very good. So you are focused on each and every data, and so drastic impact was also very clear. My question is that you might have improved the productivity also, because you have improved that now you are using ADPS for the purpose. So you should show what is the improvement in productivity also. So that is a byproduct.
Yes.
But that again matters a lot.
Yes, actually, we have not calculated all the values of the field engineer cost, because we have not taken into account the areas that we were actually incurring for the engineers to move to field each time. And multiple sea trials required the consort ships to be there's not just for the Indian, even for Indian Navy there was a cost for
Very costly method. Connecting sea trials, it involves multiple areas.